Hello and welcome to another installment in the test series for the KR01 robot. This is the KR01 robot. Today we're going to test a new Roam behavior, a single discrete behavior and a collection of behaviors as used in what's called a behavior-based system. This is based upon what is called a subsumption architecture, where behaviors are prioritized and able to subsume or override lower priority behaviors. Such a behavior can suppress or release other behaviors. Now, this is a single behavior, and the only behavior that's been implemented so far on the robot, and it uses just a single sensor. This is the center infrared sensor. It's an analog sensor that returns a voltage dependent upon the distance to an obstacle. I'm converting that voltage to a measurement in centimeters. This sensor sends messages onto a message bus with a payload containing the distance. When released or unsuppressed, Roam waits 3 seconds and then sets the robot's forward target velocity to slow, which is about 20% of its maximum speed. It listens for messages from that center infrared sensor's output, and at the maximum distance, which is configured currently to about 50 centimeters, it inserts a lambda function into the port and starboard motor controller. This lambda function returns a value at 50 centimeters of 1, and as configured at 25 centimeters, it returns a 0. So the lambda function returns a value between 1 and 0 dependent upon the input value from this infrared sensor. So its output is a function of distance. It begins limiting the top speed of the robot at the maximum distance as a ratio down to the minimum distance, where it returns a 0 and therefore stops the robot. So basically the robot moves forward until something shows up at the maximum distance, then slows down to a stop at that minimum. Once tuned properly, the idea is that the robot should never get any closer than about 25 centimeters from anything at the front. Now, if that fails, which with robotics it always fails, there's bumpers at the front that would be a different behavior that would stop the robot immediately. Now, because this is a single behavior, if the robot comes upon an object and stops, it will just sit there forever. There's no other behavior. At some point, we'll be implementing an avoidance behavior, which would maybe back up and get away from the obstacle. But we're just testing this one behavior right now. So let's give it a try. I'll start up the robot operating system. Now, normally the Roam behavior would be triggered either by another behavior or on automatically, but I'll manually start it, and in 3 seconds it begins moving forward. Now, if I put an obstacle beyond the range, nothing happens. But as soon as I move it within range, it's now slowing down a little bit, and then as we move closer, so you can see that it acts as a function of distance. If we get to this point where it has stopped, and then let's say the obstacle is removed or the cat moves away, 3 seconds later, it starts up again. So that's working on the test bench. Let's try this on the ground. Whoa, it's getting away from us. Oh, stop. Okay, here we go. If I move this out of the way past 50, it will go to full speed, well, set speed. That looks a little bit closer than 25 centimeters. So we clearly have a bit of tuning to do, but this does seem to work just fine as a single behavior. I guess the next thing would be to look at an avoidance behavior. But for now, we have another success. And so, again, thanks for watching. We look forward to seeing you again sometime in the future. Bye now.